The next object that we're going to extract is lightweight polylines. So let's just go over the high-level requirements. So from our AutoCAD drawing, we're going to extract into Excel file, and the properties this time is just limited to 4, which are the layer, line type, the length, and the coordinates of all the vertices. So this is quite different from the rest of the other objects that we have extracted earlier. The reason being is that for a single polyline there could be 2 or more vertices. So we will have a separate routine or method or function that will extract the coordinates for us and write it into Excel spreadsheet. So in the next video, we're going to start developing the methods to extract or to export the polylines. I'll see you there. Welcome back. In this video, we're going to complete the extraction of polyline objects. So we can start with the user interface. Let's just copy one of these button here, Control C, Control V, and change the text to export polylines, and change the name to BTN export polylines. Now if we double click on this button, it should give us a blank method. We will come back in this method once we are done creating our method from the export Excel util class. So again, we can just copy the existing line of code here, the existing method. Let's copy the export line method and then put it at the bottom here, and we'll just have to change some of the code here, change the name to export polylines. Also some of the text here, replace the line with polylines. And this time, instead of passing line, we're going to pass in the lightweight polyline. So LWPolyline. Okay, and if there's no polyline found, just say that no polyline found in the drawing. And for the get Excel worksheet, same thing. We'll just have to change this to polylines as the worksheet name. And for the headers, we just need 4 headers, so we can get rid of these other extra headers here. The first one is the layer, followed by the line type, and the third one is length, and the last one is the coordinates. Alright, now we can loop through the polyline. So this is the looping structure. We have just to change some of these values here. Let's just start from the comments. So instead of a line object, we're going to use a polyline object. Okay, and again we just have to get rid of these extra columns there. So the first one is the layer. So we have here the P line dot layer. Next one is line type. Third value would be the length, and the fourth one is the coordinates. So this is a little bit tricky. The objective is to extract all the coordinates of the vertices of the polyline object. So we have to create a separate method for that, instead of us creating the code from within this for each loop here. The reason being is that we will be using that particular method once we also develop the other format like the CSV file or the pipe delimited format when we extract the polylines. So we'll just rather create a separate method for that we can just pass in the polyline object, and then it will return for us the concatenated string. Okay, so I would like that to be created in the common util class, because we will be using that in some other method calls as well. So let's go over to the common util class, and we can create here a new function called public function get polyline coordinates, and we are accepting a polyline object, so PL as polyline, and we will be returning a string, a concatenated coordinates as a string value. So how are we going to extract the coordinates of the polyline, of the vertices of the polyline? Because depending on the polyline, there could be more than two. Definitely, some polylines can have lots of, even hundreds of vertices. So to go through the one vertex at a time, we have to count the number of, we have to get the number of vertices of the polyline. So let's create a variable called dim vert count. That's just for the vertices count, and that will be equal to PL, that number of vertices. And then we can also create another variable called coord for the vertex, so that this will be the variable to store the coordinates of the vertex. And then let's create another variable called coords as a string. This will be the variable that we're going to build and then return to the calling program. And finally, let's create one more variable called I as integer. It's just basically the counter. Now we can loop through the vertices of the polyline. We can use the for loop. So for I equals to 0 to vert count minus 1. So this means that we are going to start from the first array, the first vertex, because in VB.NET the array is 0 based basically. So we can store now the first vertex into our coord variable. This will be equal to PL that get point to the at. This is a built-in function that gives you the coordinates of the vertex where you are in the array. I mean, where you are in the polyline. So you are looping basically one vertex at a time based on this index here, or the counter. So we'll use this and pass on the I as our index. So every time we increment the I, it moves to the next vertex. And then we can store the coords or the coordinates into the coords variable. So we're going to use the concatenation expression, the plus equals. So coord 0, that is the x coordinate, plus coord 1, that is the y coordinate. Then we have to convert it to string. Forget the plus here, to string. Okay. So this is for the first one. Now we have to make sure that if the I is less than vert count minus 1, for as long as it's not reaching the end of the vertices, then we need to add extra comma. Then when we reach the end of the vertex, then we don't need to add extra comma here. Okay, so otherwise, if we don't add this comma, we will have a malformed list, which means that one of our or more coordinates will be joined together without a separator. So we need to put a comma here. And that's it. We need to just pass on the next I. So this will take care for gathering all the coordinates and storing it in the coords variable. Then all we need to do now is return that value. And that's it. So now we can call this method from within our extract polylines method here by basically getting the coordinates, get the coordinates. So we will be needing a coords variable to store the coordinates that we will receive from the method. So let's just add another variable here, dim coords as a string. Initialize it to an empty string. So now we can store the coordinates that we received from the common util that get polyline coordinates method, where we're passing here the polyline object. And now that we have that, all we need to do now is to add into the range. Basically add into the column D, that value would be now the coords. And that's it. So now we have all the properties that we need. We have the layer, we have the line type, we have the length, and we have the coordinates. And here, just change the messaging here to be consistent. And this will be our method. So in the next video, we're going to give this a try. Before that, let me just go back to the form util, and now we can populate this code here. We'll just copy that over and then change this to export polylines. And that's it. So in the next video, we will try running our code and see how it goes. I'll see you there. Okay, so now we are ready to test our plugin. Let's do a rebuild here. And it succeeded, so let's load our plugin into AutoCAD. Net load. This will be our plugin here. So before we run our code, let us first select the polylines here just to check how many polylines we have. This one. If we use the AutoLisp to get all the lines, P-lines, we have 9 polylines. Alright, so our plugin is show Excel util form. Now we have the export polyline button here. Let's give it a try. Nice. It says successfully extracted polylines to Excel. And here's our Excel file. So these are the 4 columns that we have. We have the layer, we have the line type, we have the length, and finally we have the coordinates. So our coordinates is just one column, however they are separated by a comma here. So for each vertex we have a pair of x and y coordinates all the way to I don't know how far this is can go. Alright, there you go. So that's it. That's how it is to extract the polyline objects into Excel file. Okay, I'll see you in the next video.